All right, let's try 11.4, number 44. So I have a 6 by 8 piece of, what?
11.3?
Oh yeah, like I said, 11.3, number 44. So we have a 6 by 8 piece of tin, right? And we're going to cut squares of equal size out of each corner and make a box. Okay, so we're going to cut some squares out of the corners. Is all good with that? Mm-hmm. And then we're going to throw those away, right? And then we're going to fold this up and make a box. Cool. All right. So, even lamer. Let x denote the side length of each cutout square. Okay, so I put x's in there. What else do I know? Yeah, they're squares, right? So the other side's also x on all of them?
Wait, then if you fold it up, it won't make a square.
Yeah, it's not going to make a cube. It's going to make a rectangular box. Yeah. So we're going to cut those out. We're going to throw them away, right? And then we're going to fold this up, and it's going to make a rectangular box with an open top. Okay, so I think probably part A. Find a formula for the volume of the box as a function of x. Okay, cool. What's a volume?
The amount of 3D space an object takes up.
Okay, cool.
Those side links, 8 and 6, still.
Oh yeah, so those are no longer those sides.
That's 8 minus 2x and 6 minus 2x now.
Oh, good, Alvin. You guys see that? So this side in here, right, is 8 minus 2x. And this side across the bottom, maybe, is what?
6 minus 2x.
6 minus 2x. Okay, so my volume's going to be...
times height.
Okay, so 8 minus 2x times 6 minus 2x. How tall is it going to be?
X.
X. Good. Cool. Yes? Okay. That's my volume function, or my volume as a function of x, right? I'm thinking length, width, height. Great. Deal. B. For what values of x does this formula make sense?
Positive numbers.
In other words, what's the domain of B?
You can't have negatives because then, unless you fold it the other way, does that count?
Okay, so yeah, I don't know what it means to cut an anti-square out of this thing, right? That would probably look like this. I don't know how to fold this into a box anymore. I don't even know what the hell sense this makes, right? Okay, so I'm probably going to pitch the idea of negative x's. So x's have to be bigger than 0. Do I put an equal to here? Why not?
Because you don't get a box.
Oh, yeah, okay, because it's hard to count the flat sheet of tin as a box. I'm going to count it as a box. It's a shit box, but whatever. Okay. That one's definitely up for debate. I would definitely go along with you if you don't want to include that one. What else doesn't make sense for x? Where's it stop making sense?
Oh, maybe if you...
Where's the other shitty box, right? Like, not this one, but what if I did this?
Make another rectangle. That's what you're saying?
You guys see that? Like, if I increase x, right, they hit at some point. They hit along the short side. So I'm going to throw that crap away and this crap away, and I'm going to be left with a different rectangle.
Should be less than 6 or.
Yeah, so when do they hit?
6 minus 2x.
Yeah, they hit when 6 minus 2x is...
Is equal to 6. I don't know.
Yeah, when x is equals.
So they
three
hit
to
when
three.
I'm throwing that whole side away, right? So they hit when 2x equals 6.
So x is.
Oh,
Yeah, so x is 3, right? The whole side's 6. If you cut 3 out of each side and toss them,
They're gonna meet.
you're done with that,
Yeah.
right? So I think the biggest x can be is 3.
So we got 3, 2, and.
No.
Yeah, infinitely numbered, many numbers in between.
Yeah, there's lots of numbers in between 0 and 3, right?
Can it actually be 3 though? Because then we're just cutting off the side.
Yeah, so like I said, these are up for debate. Maybe the best way to do it is to say that, because if you cut off 0 or 3, it's hard to fold.
Oh, because if your argument with 0 is that you just have a flat sheet, and with 3 you would just have it on a flat sheet.
Yeah.
So that's what you.
It's a stupid box, right?
Yeah.
It doesn't hold anything.
Well, you still could. You just pick it up, make sure it doesn't roll out. I guess.
You can set things on it.
Yeah.
Breakdance on it.
All right, so yeah, I think maybe 0 to 3 and with equals or not doesn't really matter, but pick one. All right, sketch a graph of the volume function. Okay, so for part C, what do I know about this thing?
Well, you got
X
x.
is 3 degree, I think, right?
Yeah, so this is a cubic, right? You guys all see that?
Yeah.
What's the leading coefficient going to be?
X cubed.
In other words, if I multiply this out, right, I'm going to get some x cubed plus some other garbage, right?
4?
Yeah, 4, right? It's going to be that. So the coefficient on x is 1. Coefficient on this guy is -2. Coefficient on that guy is -2. So I'm going to have 4, which I'm thinking of as 1 times -2 times -2. That's cool.
Really weird graph.
Okay, hang on. So I don't care about the rest. I only care that this is,
Oh, that it's positive.
yeah, I only really even care that it's positive, right? So that I know that this thing looks like this, more or less, right? Like if I zoom out far enough, it's an odd degree and an even coefficient, or sorry, a positive coefficient. So it's looking like a regular right side up whoopty.
So should we just draw the hoopty and then take away the x's that don't count?
Yeah, so that's exactly what we're going to do. We're going to draw the whole whoopty and then just cut the ones that don't make any sense. So where do I know this thing goes through 0? In other words, take v of x, set it equal to 0. When's the volume 0?
0.
When X
And
is
then
0.
Yeah, okay, so when you don't cut anything off, right? When you cut 3 off, and then it's 0 again in a really weird spot. Doesn't make physical sense, but when is this formula 0? Yeah, at 4, too. You guys with me on that?
Oh, I got 2 and 4 is 8 and 0.
I get a factor of 0 in there. Hell if I know what that means anymore. Right? It doesn't make physical sense, but it comes out in the math at least that there's a 0 there. So my function looks like a whoopty that goes through those 3, right? So it goes down here, up there, and then I just need to make my little whoopty connecting, right? So that's going to look like,
Didn't cut 4 out.
Yeah, he's just drawing it.
yeah, so this is the full v of x, right? And then if I restrict to the domain of v, right, the natural domain here, I really only have this part. And I guess you guys said those weren't supposed to be in there, so I'm opening those. You guys cool with this? The blue thing is, once we've talked about reality, this kind of thing up here has a native drawing that's the whole thing.
I kind of like what's going on between 3 and 4. It's kind of weird.
Yeah, that one's a little bit strange, right? The volume's like negative in there.
That's what it's cut out, though. 'Cause it-
Yeah, I don't even know what the heck that thing looks like, right? That's like, you cut out a box like this, and a box like that, and I don't know what it means to throw away something that I already cut out. You see that? Like, this doesn't make any sense. All right, so D, where's the maximum volume?
We can punch that in the calculator and we can.
1.5.
Good, you can punch it in a calculator or you could kind of guess. It's probably not symmetrical. So 1.5 is a decent guess. My feeling just from drawing this picture, right, is that it's probably pushed a bit right. What's up?
The tangent line is 0.
Yeah. So if we had a calculus tool, right, we're looking for that flat spot. So we'd be finding a tangent line and then setting the slope of the tangent line equal to 0 and solving. You guys see that? Like that's really what that top guy corresponds to. But without that tool, I can really only guess. So I would guess, personally, something around 2. Anybody got a guess out of a calculator?
We divide between, split 0 and 3 in half. And
Yeah, so that was Ethan's original guess. That's also a good guess.
I got 24.
You got what now?
24. That's the,
then 24?
as the
As the Y?
maximum. Yeah.
I got it.
Oh yeah, but oh damn it, I'm skewed the wrong way. Poops. Okay, so out of the calculator we get 1.13. I guess my picture skewed the wrong direction. Drat.
Oh, you were asking for the X. Sorry. I'm for
Yeah.
the Y. My bad.
And then the Y that goes with that, right? So this is the X max. And the Y max, in there at least, is like 24.3. What does that mean?
The volume at that. And with that X,
Get
the
out of
volume.
it is 24.
Yeah, the most you can get out of this thing is 24.3 cubic inches. And you get that when your X's that you cut out are 1 inch and an eighth. That's cool.
Yeah, because as you decrease it, you're decreasing the depth of the box.
Yeah, you're kind of playing this game, right? Like, as you make the X's bigger, right, the box gets skinnier, the base gets smaller.
It's deeper.
But it gets deeper, so like for a while that's good, and then after some sweet spot you're kind of losing more and more volume. So this is where that sweet spot is, right? It's at X is 1.13, and then the kind of sweet spot in terms of volume is 24.3 cubic inches. That's another one of those, you're never going to be able to fit 26 cubic inches of water in this thing, it's just not going to work. That gets your question in there, kind of? Cool. Anything else on this one?